Hello everyone. Today I'm gonna start with the stoichiometry calculation. So there are total three types of conversions: mole to mole conversions, mole to mass conversion or mass to mole conversion, and mass to mass conversion. So I'm gonna start with the first one, mole to mole conversion. So I will take you with the problem step by step. So I have a few questions here. So yes, let's check our first problem. So let's read the question first. How many moles of nitric oxide are produced in the reaction if 15 moles of water are also produced? So first of all, you should know the chemical reaction. I have a chemical reactions already written here for the problem. So they in this chemical equation, ammonia reacting with the oxygen and form water with the nitric oxide. So I will say before you jump to the stoichiometry calculations, first of all, circle all the coefficients, circle or underline. So here with the ammonia coefficient is 4, with the oxygen coefficient is 5, with the water coefficient is 6, with the nitric oxide coefficient is 4. Because coefficient means moles. So because we need this mole in your calculation. So now our moles are ready in terms of coefficient. And how to proceed with the stoichiometry calculation? Same method, same pattern, which I have already discussed in my mole concept calculation. So first column, what do you know as a value from the question? So if I go with the first question, I know the value is 15 moles of water. All right, here we go. Then you will write with the third column first. What do you need to find? So I will go back to my question. My question said how many moles of nitric oxide are produced. So it means I need to find uh, moles of nitric oxide. Here we go. And in the first column, you will write 15 moles of water. Here we go. Okay, so on the middle column, that is your conversion factor in terms of your mole ratio from the balance equation. So it means in the conversion factor, I need water and nitric oxide. Forget about other moles. So this is how we proceed with the stoichiometry calculation. So if I go my balanced chemical equation, in balance equation, I have 6 moles of water and I have 4 moles of nitric oxide. Okay, here we go. So I will write down this number one more time so that I can show you how to proceed with the question. So in the first column, I have 15 moles of water. Make sure you write with the formula moles and water. Then it's very easy to do these calculations. If we just write the number, then we forget what should be our conversion factor. So my question said I need to find moles of nitric oxide. So it means I don't need nitric oxide and I need water. So your conversion factor means a ratio. So conversion factor surrounds with water and nitric oxide. You want to cancel the water, write down 6 moles from the balance equation. 6 moles of water as a denominator. You need answer in terms of nitric oxide, write down 4 moles of nitric oxide at the top. Now you can see why I'm uh, first more for writing the units in terms of formula. So you can see because it's a dimensional analysis, same method, same formula, that similar units should be cancelled. They should not be multiplied. If you're multiplying same unit, it means you're writing the wrong conversion factor. You can see I can cancel moles water. There we go. So I'm left with moles of nitric oxide. This is what I need. And rest is your calculation and we can find the answer. Here we go, and I tried to do calculations without calculator, so it looks like my answer is 10. So here we go. So this was the first part of the question. So you can see I have written two questions together with the same chemical equation. I will show you the second question now. So second question is how many moles of water? So now it's opposite. How many moles of how many moles of water you need to proceed? This is my question mark. And what is given to me? 2 moles of oxygen. So let me show you the same steps, same 3 columns. Then it's very easy to do stoichiometry. Stoichiometry is not difficult. It is just the little trick. So what do you know in terms of a number from the question? I know 2 moles of oxygen. Here we go. What do you want to find? I need answer in terms of water moles. Here we go. So it means in my conversion factor, I need moles of oxygen and moles of water. Forget about the other moles. So what do you have? How many moles you have in the balance equation for oxygen? I have 5 moles of oxygen and I have 6 moles of water. So it means my conversion factor have ratio of 5 moles of oxygen and 6 moles of water. So we are connecting basically unknown information from the known molar ratio from the balance equation. So now you want to cancel the moles of oxygen. You will write 5 moles of oxygen as a denominator and 6 moles of water as a numerator. So you can see moles of water out and moles of water in. So it's 12 divided by 5. So answer is 2.4 moles of water. Here we go. So these are the two problems. I have one more problem to show you. So same thing, because we are doing mole to mole conversion. First of all, we should have the balance equation. Same thing. Circle all the coefficient. Coefficient means the big number in front of the formula. Here we have 2 moles of aluminum, means 2 is the coefficient. 6 moles of hydrochloric acid means 6 is the coefficient for HCl. And 2 moles of aluminum chloride, 2 is the coefficient. And how many moles of hydrogen we produce? We produce 3 moles of hydrogen. So 3 is the coefficient. So 3 columns. What do you know as a number? So let's read the question. A student reacts 5.25 moles of aluminum metal with plenty or excess of hydrochloric acid. How many moles of hydrogen gas are produced? So what do you know in the first column? So I know 5.25 moles of aluminum metal. Make sure write down units with the formula. Otherwise, you will be confused what should go in the middle column. What do you want to find? I want to find moles of hydrogen gas. So this is my third column. Moles of hydrogen gas. And now you know, based on the previous two problems, so what will be in my middle column? Conversion factor from balance equation. So I need moles of aluminum and moles of hydrogen. Forget about the other moles. So how many moles of aluminum you have reacted in the balance equation? That is 2 moles of aluminum. And how many moles of hydrogen you have produced? 3 moles of hydrogen we produce. You can see I can cancel moles of aluminum. So here we go. So this line, so usually I use the word, this is the bridge. Whatever is over the bridge, they multiply. Whatever is under the bridge, they divide. We cancel. So you are canceling these same units. If you have written moles of hydrogen as a denominator, moles of aluminum as a numerator, which is wrong, because we cannot cancel aluminum with the hydrogen. Same formula and same unit should be cancelled. So I think I need better. I need to use the calculator here. So I have to multiply 5.25 times 3 and divided by 2, which is 7.785, 7.7875, or we can round up to 8 moles of hydrogen gas. So I hope it will help you. So next week I will show you, I will take you step by step how to do the stoichiometry conversion for moles to mass and mass to moles. Thank you.